30.
Number 30. So let's take a look at 30. Verify that these guys are inverse functions. So in order to tell if these guys are going to be inverse functions, that didn't work. There we go. To verify that these guys are going to be inverses of one another, what we have to be able to do is take f of g of x and g of f of x. And if you simplify that out, you should both get the same answer. What should that answer be? It's 1x. Yeah, it should just be x. So we check what is f of g of x and what is g of f of x. So you substitute in 3x to the 1/2 squared times 1/3. Okay? So now, what you wind up with here is that you've got 3x, you've got the square root of all that junk. So you've got the square root of junk squared. What's your answer? Junk. What's the junk here?
3x.
3x. So you wind up with 3x over 3, which is x. Okay? Do the same thing, g of f of x. So I take the 1/3 x squared, times 3, the half power. What's 3 times a third? 1. So now I have the square root of x squared. What's the square root of x squared? X. Are those inverses of one another? And that's how you verify. Okay? 38. Okay. Mind if I do 32 because it's right here? I'll go to. Verify we have inverses. So, f of g of x. So we take 256 times 4th root of x over 4 to the 4th power. What's 4 to the 4th power? 256. 4th root of x to the 4th power. Bless you. X. Got you. So it's 256 x over 256. Oops. Which is x. Okay? Go the other direction. 4th root of 256 x to the 4th all over 4. What's the 4th root of 256? 4. 4th root of x to the 4th. And you're left with okay.
Yeah.
Find the inverse of the power function. So remember, this means y equals 3x to the 4th. Interchange x and y. Solve for y. Okay. Can you have a radical in the denominator? No. So we have to get 4th root x, 4th root of 3. So to make that go away with to the 4th root of 3 times 3 times 3. What I'm doing here is I'm creating a perfect 4th root So that just means I have to add 3 more 3's together. So 3 times 3 times 3, that's 3. The fourth root of that is 3. Yeah.
Where's the horizontal line test in the blue?
What do you graph?
So you didn't even do it like this stuff?
Not in here. I don't think it said you had to graph it first. It just said find the inverse. But then, in this case, it was asking for just the values. See how I take the fourth root? It could be plus or minus. It just wants the values that are negative, so I got to slap a negative here to make the answer correct for what this problem's about. Okay. Now, with the fourth root of this one, this one's kind of a weird fourth root. Doesn't really switch things around all that much. So that way, it just looks like a regular old boring parabola. Yeah. I'm creating a fourth root. What's 3 times 27? Okay. That's what I'm doing. Does that make sense, Rod? What else, ladies and gentlemen? Yeah. I broke the stapler earlier, but I dropped it.
It's not broken, you just clogged some of them together. Oh, whoops, it exploded.
Don't poke your eye out.
It just exploded.
Once again, y equals 2 minus 2x squared. Interchange x and y.
How is that even possible? Why?
I don't know what I did.
No, it's just all clogged up at the end. I mean, I know how to get it unclogged. I'm doing it right now, but...
I'm just going to bring the negative 2y squared to the other side. So I have 2y squared is 2 minus x. Is that okay? Divide everything by 2. You take the square root. And then you just have to get rid of that radical in the denominator. So you wind up with 2 minus x times the square root of 2 all over 2. Which is 4 minus 2x over 2. And I think this problem also is looking for the negative values. So you just slap a negative here. Okay? You don't like rationalizing, I can tell it. All right? Okay?
Yeah, it's fixed.
Thanks, man. I appreciate it.
Let me just put the rest of them in here.
Make sure you say hi to the people on the internet.
Oh, whoops. We're recording, aren't we?
Make sure your name's Rob.